Alright ninjas, let's go another 7 Caillou challenge called Chain Me. Write a generic function chainer that takes a starting value and an array of functions to execute on it. The input for each function is the output of the previous function, except the first function, which takes the starting value as its input. Return the final value after execution is complete. Let's look at the example. Consider you are passed the input value of 2, okay? And then they have a couple methods written out here, an add and a multiply, right? So it would go through the add first, then the multiply. You would add 2 plus 1, you have 3 at this point. You'd pass 3 to multiply, 3 by 30 is 90. So where this might become a little uncomfortable for you, you should see that the connection to the challenge, before I get ahead of myself, is this kata chain. Remember, input matches what we have here, and then they're making an array of these functions that take a double and return a double. And we'll look at this, we'll use the docs and go over this to make sure you're comfortable, but that might be a little unfamiliar at this point. But look, all it means is, remember, with this func, it represents a function. It'll list all the parameters first, and then at the end, it lists the result type, the return type, I should say. So notice how these take one double and return a double. Take one double, return a double. These fulfill this type, and therefore you could add them to an array of that type. If this method add instead returned a string or an integer, something like that, it would no longer be compatible with this type, and you couldn't add it to the array. So we'll take another look at that, but I just wanted to give you enough to get started, and you know what to do. You can pause, try this out, see what you come up with, and then resume when you're ready. So for my first solution, I'm just going to basically loop over the functions and keep incrementing the result. I'll start with a variable that's set to the input value that's passed in here, and then we'll just go through the collection of functions and keep calling them and return what we get. So let's start out. Spelling matters. Double val. Remember, we'll start it at input to start. Input could be 0, it could be 27, whatever. We don't care. Then we need to go over each of the functions in the array. So I'll use a for each loop, and the type is this func double. And I'll call mine func. It's okay, I'm using lowercase f, shouldn't be a problem, in fs, which is, I think, short for functions. You could write that out as functions if it's easier to visualize. And then in here, basically what we'll do is, like I said, we'll just call func, right? Func's going to be populated with each element of this array, right? Starting from the beginning. And so we have to update the value, right? Val equals func called on the previous result. And remember, the first time we don't have a previous result, so it's just the input value to start. But each time though, val will get updated with whatever the last call to func of val was. Finally, when you're done, you should be able to return that value. And I'll run a test. Okay, so that's fair. Type or namespace func cannot be found. That's okay, we wanted to look at that anyway. So if you look this up in the Microsoft docs, you will land here, and you'll notice here's action, which is a kind that returns void, but if we scroll down, see all these funcs? And like I said, they have all these different kinds, but the result is always the last. So imagine you had a function that took an int first, a string second, and it returned a string, you know, so it could look like int, string, string, or whatever you want them to be. But that's all it is. Whatever value is last, and they aptly named that t result. It's the return type. So you can see that it encapsulates a method that has one parameter in this case, right? If you went to one of these other ones, it would say it has more parameters, but we just have t here, so it has one, and returns a value of the type specified by the result parameter. And that's what we had in our example, right? We had double to double. So you can imagine looking at this, t would be double and t result would be double. They don't have to be the same, but they are in this case. So feel free to read about these all you like if you'd like some more information on that. But I think that description was very fitting. It's just something to encapsulate a method with a given signature, right? Methods are defined by their signatures and their names, you know, but we know in programming you can have overloading where you have multiple methods with the same name. And in that case, they have to have different parameters, right? So I think we're good there. And let's look at the instructions for a minute. And like I said, these did work, right? Because you had double to double, takes a double, returns a double. Good. And so those can be populated in, but you could have any method you want. You know, instead of add and multiply, you could have divide or make up your own thing, you know, triple, whatever. And they all work. So I will hit the larger suite just to make sure this is right. Oh, that's right. We didn't take care of the error. So if you'll notice, right, what do? We always check out when we get those kind of errors. We could see you need the system namespace to use this, right? Because we didn't make up func. We didn't define that. So we're using the library, the system namespace. So we got to bring that in so they know what we mean. Okay, looks good. Looks good. And you can see they had all these different kinds of tests, subtraction, multiply. That's good. We hit them. I'm going to go ahead and show you a way to do this with LINQ as well, if you'd like to stick around for the extra credit. But hopefully that's clear. You're just calling all these functions, and hopefully you could see the power of this, right? You could have one series of calculations that you wanted to do, and then if something changed, your goals changed, you could put a different set of functions in there to see, or maybe to experiment with a different scenario, right? And you would load this array up with some other functions. So it's cool, it's powerful. But let's get on to the extra credit. Let's do the LINQ. So let's try not to get yelled at like we did here. We'll just bring in LINQ now. So I don't need this. What I want you to do though is a good challenge. Remember on the docs page how we keep that enumerable page open with the method list in there? I want you to look through that and just see if you can find something just by name only. You don't have to click on all of them, but see if you can find something that sounds like it would achieve what we want, where you're sort of accumulating a value over, you're running a bunch of steps, you're going over a collection, and you're sort of accumulating this val, what we called here. And hopefully you can find that. So I will go to it. Very first one, hopefully you found that aggregate is kind of like accumulate, or it should, like you're kind of compiling something, and hopefully that triggered for you. And it's a good practice, right? Like anytime you have problems come up and that spidey sense goes off and you're like, this seems really common. I'm sure somebody has done this problem before. You go scan through these and see if anything Sounds like it fits. In our case, it does. Enumerable aggregate. Applies an accumulator function over a sequence. The specified seed value is used as the initial accumulator value. So don't be intimidated by that seed value. It's just the initial value, right? Seed's a fancy computer science term. And the specified function is used to select the result value. So let's check out this overload. There's 3 here, but I like these ones that have initial values, right? Because they're giving us that input parameter. So I'm going to use one of these. And I like to go down to the example, but you may read all you want. And this will give you an idea of how you might use it. In this case, they're looking for the longest name in a collection, right? And they're going to start with banana as sort of the baseline. They're going to pass 2 parameters there. One's going to be like the total, and one's just going to represent the element, each element in the fruits collection, which would be like next here. Remember, longest would be banana to start. The first time you come, it would assume bananas the longest, and it would compare against apple first, then mango, then orange. You can see passion fruit's going to win there. And yeah, it'll just step over each element, and it will keep updating longest as needed. And hopefully you kind of see the similarity to the problem that we have. We don't have fruits, we have an array of functions. And instead of a string, we have a double value that we need to keep adding to. And in this case, it looks like they're like the longest would just get updated, but we're gonna, and that's like what we're doing, right? We're gonna keep updating our input value. So let's make that connection, right? We take our list of functions, right? And we know our methods, aggregate. And what came first? It was that seed value, right? So what's that in our case? Well, they gave it to us, input. Oftentimes, if you're doing calculations, it could be 0 if you're adding something up. But they're giving it to us in this case. Now we're going to have 2 parameters like they did, right? The first one's going to be the total, and the second one's going to represent each element in the fruit array. You know, maybe I would have called this fruit instead of next, but we don't need to nitpick over that. So I'll call mine, I'll call it result instead of total, because it's not like we're necessarily adding them, we just keep updating it. So result, and then since we have a list or an array of functions, I'm just going to use func for the variable name for each element in this fs array. So good, we have our parameter list, right? We're building a lambda function here. Then we put our arrow after we've defined our parameter list, and we can write the method body. And so what's the quantity each time? Well, if you want, pause it and go for it. Otherwise, I'll get right into it. Func of the result, right? I think that would do it. Each time we're calling whatever the current function is, right? First time it'll be the first element, second element, third element, etc. And each time it's going to call func result and update result with whatever this returns. And result will keep getting updated. Func will be its index incremented, or you can think of it as being the next index in the array, etc. And so if we go back to aggregate, check its return type, it returns t-result, the transformed final accumulator value. Remember, we said t-result was a double in our case. So it's going to return a double. That meets what we're looking for, right? That fulfills the contract of the chain method. So let's tell it to return that and give this a go. Good. We'll hit it again. I'm going to delete this because I'm going to end up submitting my one-line answer. Don't know if we need system anymore. Let's attempt. Oh yeah, I did for func. That's right. My mistake. Attempt it. Nice. All green. So yeah, this is probably a little bit different. You're used to just simple arrays that have either ints in them or strings, and now you got to think about it like, okay, now they're a function. That's weird, an array of functions. But it's just like what you've been doing, right? We're calling this LINQ method that runs over each element of the collection, right? With aggregate, we were offered this option to give it a starting value for the total. Remember, input, whatever they pass in, and result in our parameter list is going to have this input value to start. Func will be populated with the first element in the array, and then each time this runs, right? So to start, result equals input, then you're going to call func on the input value, and that's going to update result. Then on your next time, result's going to be that new value. Func will be the second function in the array, and it'll call that second function on your previous result. You get a new value in result, this becomes your third function, etc., all the way to the end. Really nice, short, concise solution there. So we'll check out what other people did. As always, I'm going to submit this and get my points. Looks good. And then yeah, do your work. See if you can learn anything from what other people did. Take a quick scan. Seeing a lot of aggregates in there. But other than that, hit me up with questions if you have them. Otherwise, I will see you in the next challenge.